Hello students, welcome to the next lecture on the absolute maxima and minima of the function. That means how you can find the absolute maxima and the minimum value of the any of the function fxy. Myself Dr. Garg, working in the School of Mathematics Thapar Institute. You can simply follow my YouTube channel Dr. Harish Garg, where you can find the various videos on the mathematics 1. So what we have learned in this lecture, we will try to find how you can solve the problem of the function fxy and how you can find the absolute maxima and minima on the closed bounded region. What is the meaning of this closed bounded region? Firstly, so look at that. If you have any of the region R which is a closed form, or if you have any of, say, this the triangular region which is the closed, which is bounded by the O, A and B, you can see these are closed are there. So my objective is to find if you have defined a function fxy and how you can find the maxima minima inside this closed region instead of the whole R2 plane. How you can find that? Before finding this absolute maxima minima, there is a slightly terms are there. Whenever you set extreme point, that is either the maxima or minima will always exist at the critical point, that is called as the interior points, or at these boundary points O, A or B, or you can say or at either of these boundary points. All are my boundary points are there. So maximum and minima will exist either of these blue dots or else are inside these points are there. So what is the critical point? Any point, any interior point, say this point A comma B is said to be the critical point whenever the partial derivative of this function f with respect to x and y are 0 or either one of them does not exist is called as the critical point. How you can find the absolute maxima minima? I will state with the two-step rule. First step is you can find the critical point by taking the first derivative as a 0, first derivative with respect to x and y 0. Second step is we can list about all those boundary points on the region. So if my this is my region, then if I consider O, A, B, so my boundary points are my O, A and B, and then we can find its critical points. After collecting all those points, we will check which one is the maxima or minima. For example, you can see there, find the absolute maxima and minima of the function. So that's very simple, which is on the first quadrant bounded by here. Firstly, we will try to step 1, find the critical point. So what is the partial derivative of f with respect to x? It's a 2 minus of 2x0. With respect to y is my 2 minus of 2y0. So clearly says that after solving this, you can get x as a 1, y as a 1. Therefore, 1 comma 1 is my critical point. Once you know this critical point, calculate its value at 1 here. You can substitute this value here. You will get the answers of this. Now we can draw these boundary regions. So x is 0, y is 0, and here this is my bounded region. So this is my bounded region. So now what you can do, step number 2, we can start from the line OA. So we can check on the OA. What is the value of the OA? That is my y is equal to 0. So on the line segment OA, y is 0. What are the boundary points of the OA? What are the boundary points of the OA? What are the coordinates of the O? That is my 0, 0. What is the coordinate of the A? You can see this is the point of intersection of 9, 0. So these are my boundary points. Fine. So 0, 0, 9, 0. Now what is the value of the f? So we can substitute on the line OA, we can substitute y is equal to 0 here. So that's a function of the x only. So 2 plus 2x minus of x cube. That is my here. Now we can find the critical point. Take the first derivative as a 0. So what is that? This 2 minus of 2x is 0. So we can get x as a 1. Therefore, x is 1. On this region A, y is my 0 is the critical point. Now check whether 1, 0 lies here. Yes, it lies because this point is my 9, 0. So once it lies in here. So therefore, we can again find the critical value 1, 0. What are the boundary points? 0, 0. What are the other second boundary point is 9, 0. We can compute this value. Either you can substitute here or else you can simply substitute in here. You can get the right answer in the quick manner. So you can say it's at 1 it will be my 3, it's my 0, and at the 9, so it's a 2 plus 18 minus of 84. 1. So we can substitute, we can get here. So this is about the line OA. Now similarly we can check for the line AB. On this line AB, what is the value of the y? Y is nothing but my 9 minus x. What is the coordinate of this boundary point? It's 9 comma 0, and this is my 0 comma 9. We can substitute this value of y in here. We can get the value of f is there. Again we can take the first derivative as a 0. We can get as a minus 4x plus 18 is 0. We can find the value of the x as 4.5. So y is my 9 minus x. So x is 4.5. What is the value of the 9 minus is again here. Therefore, we can find the value of this 4.5 comma 4.5. What are the boundary points? It's a 0 comma 9, and the second boundary point is 9 comma 0. Either you can substitute here, or else you can substitute here. You will get the same answer of this. Now the third line is you can go for the B to O. So on the line OB, what is that? Is x is equal to 0. We can substitute the x is 0 here. This is a function of the y now. So it's a 2 plus 2y minus of y square. What are the boundary points? It's a 0 comma 0. This is my 0 comma 9. So now you can take the first derivative 0. You can get the value of the y as here. So y is equal to 1, x is 0. So 0 comma 1 is the critical point. Now again we can compute the value as the critical point. We can compute the values at the boundaries. We can get this value as here. Either you can substitute this, or you can substitute here. You can get the same answer. Now since all are completed, so what you can do now, you can find the maxima and minima. So this is a summary of this. So this is a critical point. These are the reason are. What is the maximum value? You can see the maximum value is my 4. Coordinate point is 1 comma 0. So absolute maximum is my here. What is the minimum is? This is the minimum. This is the minimum. This is the minimum, and this is the minimum. So all are occurring at the point 0 comma 9, 9 comma 0, and they are same. So 0 comma 9 is the required answer. Look at the next example so that you may learn easy manner. So again you have to find the absolute maxima and minima. So we will apply the step number 1. Find the critical points. You can solve it. You can easily solve with the help of the calculator. You will get this as a critical points, and the answer are here. You can draw the graph of this. So this is my x, this is my y. X is equal to 0. This is line x is 0. X is equal to 5. This is my line x is equal to 5. Y is equal to minus 3. This is the line of y is equal to minus 3. And this is the line of y is equal to 0. So this is my common portion. So I can call as OABC. So it means we can start from the firstly OA, and then we can go for the AB, then for the BC, and then from the CO. On the line OA, x is my 0. Fine. So we can substitute here. You will get the function of the y. So that is my y square. X is 0. So on the line x 0, this is 0, this is 0, this is 0. Y square plus 2 is my here. And on the line OA, what are the coordinate points? This is my origin 0 comma 0. This is the line of y is minus 3. So coordinates are here. We can substitute this value here. You will get this answer. You can take the first derivative 0. You can by 2y is 0. It means y is equal to. So what is the value of the x in the line is 0. Y is 0 is my critical point. So we can compute the value at 0 comma 0. We can compute the values at the boundaries. So boundaries again 0 0. So there is no need to write again. So you can either write here, or you can substitute directly in this case. So in this case y is 0. So answer is 2. This is 9 plus 2 is 11. Now this is a line about OA. Now we can check about the line AB. On the line AB, what is that? This line is given to you, y is minus 3. So on the line AB, y is minus 3. What are the coordinates is? This is my 0 comma minus 3. What is the coordinate of B? This is y is 5 comma minus 3. We can substitute this y here. You will get the function of the x. Take the first derivative 0. You can get the value of the here. So x is my 4.5. Clearly says that x 4 point lies in between them. If it is lies outside the domain, then you can neglect them. Now at this point, so we can at x is 4.5, y is equal to minus 3. So the critical point is my here. We can compute the value at the critical point. We can compute the values at this boundary region. you can substitute directly at here for the easy calculation. So this is AB. Now we can do for this BC. On the line BC, x is equal to 5 is given to you. What are the coordinates? This is 5 comma minus 3. This is my 5 comma 0. I can substitute x is equal to 5 in here. You can get the value of this. Take the first derivative 0. We can get the value of minus 2.5. Again, you can see minus 2.5 lies here in between this region. What is the coordinate is? X is my 5. Y is my minus 2.5 is my critical point. Now you can compute the value at the critical point at these two boundary points. You can substitute directly at here. Now we can check about the point on the line segment CO. On the line segment CO, y is 0 is my here. Coordinates are my 5 comma 0, 0 comma 0. We can substitute here this. Take the first derivative 0, find the critical point. 2x minus 6 is 0. X is my 3. So therefore x is 3. On this line segment, y is my 0. So 3 comma 0 is my critical point. Therefore we can compute the value at 3 comma 0. We can compute the values at the boundary points. We can compute the values at 5 comma 0. But if 5 comma 0 we already compute, so there is no need to write. But if you want to write, then again there is no problem. You can substitute directly at here. It's a 9 minus 18 plus 2, 0, 5 and so on. You can get the values as here. Now since all these covers are there, now we can check the common points from maxima and minima from this and the other two portions. So from here you can get the maximum values at 11, minimum values at minus of 10. Look at the another example. Again, your target is to find the absolute maxima and minima. We can find the critical point. Take the first derivative. After solving, you will get the 0 comma 0 is the critical point, and the values you can substitute here. You can get as a 1. Draw the diagram of this. What is the feasible area of this? So x is 0 here, y is equal to 4. This is my y is 4, and y is equal to x is my here. So this is point corresponding to 4 comma 4 is the right figure. So we can start from here. So we can start firstly from the on the line segment OA, and then we can start from go with the AB, and then from the BO, and then we will check whether take the points from here, this and here, and then we will see about the maxima and minima. So on the line segment OA, we know that y is equal to x. Boundary points are my 0, 0 and 4 comma 4. We can substitute y is equal to x here. You can get the here. Now you can take the first derivative 0. You can find the critical point again. You can get as x 0. So therefore, when x is 0, y is equal to x is my critical point. So once you know x 0 comma 0 is the critical point, you can substitute this value here. You will get the answer as. So you have to find the value at 0 comma 0 or 4 comma 4, because we already computed the 0 comma 0, so there is no need to compute again and again. But if you want to find, you can compute this. Other point is my 4 comma 4. You can get as a 17. Now on the line segment AB, we know that on the line segment AB, y is equal to 4. Boundary points are my here. Substitute this value as y is equal to 4 here. You can get the value of f of x is this. Find the critical point of this function by taking f dash is 0. You can get as y is equal to x is equal to 2. X is 2, y is 4, so the critical point is my 2 comma 4. So we need to find the value of 2 comma 4. We need to find the value of 4 comma 4. We need to find of 0 comma 4. There is no need to compute this value again because we already compute here. So what is the value of 2 comma 4? We can substitute directly at here. X is 2, so it's a 4 minus 16 plus 17, that is nothing but 5. 0 comma 4 is 0 minus 0 plus 17 is here. So 5 and 17 are the 2 comma 4. Why is a 2 comma 4? It's 2, so it's a 2 4. Sorry, it's a 8. So it's a 16. Fine. So it's a 13 R. Now similarly on the line segment BO, what is the BO is? X is my 0, so X is my 0, and boundary points are 0 4 and 0 comma 0. Substitute X is 0 here. You can get a function of this. Find the critical point 0 comma 0. Now your target is to find the value at 0 comma 0. your target is to find the value at 0, 4. 0, 0 we already compute, there is no need to compute. 0, 4 we already compute, so there is no need to compute again. So if you want to compute, then there is no problem. Now all the boundary regions are completed. Now look about that, which value is my maximum. So out of these all regions, you can check that which value is my maximum. So you can see the 17 is my maximum and the minimum value is my 1. So minimum occurring at 0, 0. You can see the local absolute minimum is occurring at 0, 0. Maximum is occurring at 17 at the point of 17 is 4, 4. 0, 4, 4 is the same, 0, 4 is same. So 0, 4 and 4, 4 is the absolute maxima and minimum. Look what the another point is there. So again you have your target is to find the absolute maxima and minima of this function. We can start with the step number 1. Find the critical point of this function. Here, how you can solve these values? You can't divide them, because if you divide, it's a 0 by 0 is undetermined form. So now there are the two cases, either this value is a 0 or this 0. Similarly for the other half. Now clearly says that if you look about this value, sine of y is 0. What is the meaning of that? Y is nothing but my n pi. When y is equal to n pi, cos of n pi is my minus 1 raised to power is a non-zero. So it means x is my 2. So from here, you can see from the first pair, either x is 2, when the value of the cos y is 0, that is nothing but my pi by 2. Or you can write this value as 2n plus 1 pi by 2. From the second pair, you can get x as a 0 or 4, y as a 0. So therefore, what are the coordinates points? When x is 2, what are the value of y? Y is my 0. When x is 0, what are the values of y? Is a pi by 2. And when x is 4, its value is pi by 2. So these are my critical points. You can easily check that whether they are critical point or not. You can substitute here, say 2, 0. 2 into 0 is 0. 0 sine 0 is 0. So first satisfied, pi by 2 is satisfied, and here. Now you can find the values at this. Now you can draw this boundary regions. So this is my x, this is my y, x is my 1, x is my 1, x is my 3. Y is my minus pi by 4, so this is my minus pi by 4. So remember that if you think about that, minus pi by 4 is angle which is lies of this case, or this is line of the y is equal to minus pi by 4. This is the angle of the theta when you are working on the polar coordinates. When you are working on the polar coordinates, then this is the angle of minus pi by 4. But here this is a function of the Cartesian coordinates. So it means this is not the picture, this is the right diagram. Now again we will look about the points on the, say on the AB. What is the on the AB? Y is equal to minus pi by 4. I can substitute here. What are the boundary points? What are the coordinates of the A? So x is 1, y is minus pi by 4. What are the coordinates of B? X is my 3, coordinate is my minus pi by 4. Now you can substitute y is equal to pi by 4 here. What is the cos of pi by 4? Is a 1 by root 2. Now take the first derivative as a 0. We can get the value of the x as 2. Once x is 2, y is minus pi by 4 is the critical point. Now we can check the values at 2, minus pi by 4. What are the boundary points? Is a 1, minus pi by 4 and is a 3, minus pi by 4. We can substitute the value directly at here, or you can substitute directly at this point. You can get this value. Now on the line segment BC, what is given to you? X is equal to 3. Boundary points are my here, because this is my 3, minus pi by 4. This is my 3, plus pi by 4. We can substitute this value here. We can get the value of y this. And the y is 0. X is my 3. So 3, 0 is my critical point. Once you know the critical point, we can compute the value at 3, 0, critical point and the boundary points at here. Although this point we already computed, so there is no need to compute again and again. Similarly, we can compute on the line segment CD. On the line segment CD, y is equal to pi by 4 is given to you, and the boundary points are 3, pi by 4, 1, pi by 4. Substitute this y is equal to pi by 4 here. You can get the function value of this. So therefore, this is my critical point. Substitute this value, and here you can get the function's value at this. Look about the last line segment, that is the D of A. On this DA, x is equal to 1. Substitute x1 is here. You can get the boundary points, critical point as 1, 0. So compute the function values at 1, 0. Compute the function values at 1, pi by 4. Compute the function value at 1, minus pi by 4. Again, you can see that 1, pi by 4 we already compute. There is no need to compute again and again. But if you want to compute, then that is your wish. Now we compute all these boundaries. So we will look about which one is the maximum value. So this value, and the previous values are there. So from here we can see the maximum value is occurring at the 4, minimum value is at occurring 0, 5 by 2, and is my 0. Look at the last example are there. How you can find the absolute maxima minima. Again, we will firstly find the extreme critical values, and the boundary points are my here. So 0, 0 is my critical value, critical points, and this is my function value. Look at that, you can draw the graph of this. This is my x, this is my y. So x is 0 here, y is equal to 0 here, y plus 2x is my here. So this is my feasible region. So this is my boundary points. Now we can check on the points start from the OA. Y is equal to 0 is given to you. These are my boundary points. Substitute y is equal to 0 here. So x here is my function. Compute the critical point. X is 0, y is 0. So 0, 0 is critical point. We can compute the function value 0, 0 at this critical point. 0, 0 is same. It's a 1, 0. Although 0, 0 we already computed, so again there is no need to compute again. 1, 0 we can substitute here. You can get the 1, 0 as 1. On the line segment AB, we know that y is equal to 2 minus 2x. Boundary points are A and B. We can substitute the value of y at here and then compute the first derivative of 0. Once you compute them, you will get the value as 4 by 5. So what is the critical point? So x is my 4 by 5. What is the value of y? You can substitute x is my 4 by 5 here. You will get the answer as 2 by 5. Now on this we can compute the value at this point. We can compute the value at 1, 0 and 0, 2. Although 1, 0 we already computed earlier. So there is no need to compute 1, 0 again. Look at the line segment on the BO. We can compute the line segment BO. On this line segment x is 0 given. These are my boundary points. Substitute this value in the given function. We get f of y square. Take the derivative with respect to y0. We can get as y is equal to. So what is the critical point? X is my 0. Y is my 0 is the critical point. So once you know the critical point, we can substitute this value and this value is add here. So all these boundary regions completed. So we can check the absolute maxima from these 2 points, from these 2 points, from these 2 points, and the step 1 critical points are. So look at the maximum and the minimum. We can get this as the required answer. So I hope you can simply learn how you can find the absolute maximum and minima. You can see some more lectures on my playlist Mathematics 1 channel named Dr. Harish Garg, where you can find the various videos of a complete series about these topics Mathematics 1. I hope you can like, share and comment this video. You can forward this video to your friends so that they can learn this in a very simple manner. Thank you very much students. Happy learning.